Dielectric and polarization. Substances which allow electric current to pass through them are known as good conductors. Substances which allow electric current to pass through them are known as good conductors. Example: metals, human body, animal bodies are good conductors. Of electric current. Certain substances do not allow electric current to pass through them are known as bad conductors or insulators. Some substances do not allow electric current to pass through them are known as bad conductors or insulators or insulators. Example: non-metals, glass, porcelain, wood, etc. Some insulators, when placed in electric field, get polarized and produce an internal electric field, are known as dielectrics. Some insulators when placed in electric field when placed in an electric field get polarized and develop an internal field develop an internal field by which net field inside is reduced. Such substances are known as dielectrics. As dielectrics. Suppose this is the electric field. If a conductor is placed in an electric field, suppose E the external field or E the electric field, then when a conductor is placed, the charged particles inside get rearranged in a manner that they produce an internal field which is opposite the external field. This is by development or isolation of the charges. This end is negative and that end is positive. Thereby an internal field is developed, and this internal electric field is opposite the direction of external field, and thereby net field inside is zero. When a conductor is placed in an electric field, uniform in a uniform electric field E, the charged particles inside get rearranged in a manner as to oppose the external field. This internal field is suppose EI. Here E plus EI is 0. That is, internal field is opposite the direction of external field. That is, internal field intensity or internal electric field is opposite and equal to the external field, the applied external electric field. But when a dielectric is placed, but when a dielectric is placed, here there is stretching of the molecules or orientation of the molecules, or you can say that by stretching of the molecules, so dipole moment is developed in the molecules. In case of non-polar molecules, there is no net dipole moment and molecules get stretched in the presence of the external field and develop a dipole moment. And polar molecules do have some dipole moment and they get oriented along the direction of the electric field, so that one end is negative, other is positive. Negative, positive. Thereby, one end develops certain positive charge and other end develops some negative charge. But here, net charge is not zero. So, a surface charge density sigma p is developed that way and minus sigma p is developed in the other way, so that an internal electric field is also here developed. This internal field EI is opposite but not in magnitude same as the external field. When a dielectric medium is placed in a uniform electric field, E, the molecules get stretched and develop dipole moment and that is for non-polar molecules. That is S2, CO2 and CH4. And there is orientation of dipoles of the molecules. In case of polar molecules or polar substance, that is S2O, SCl, etc. These dipoles get aligned along the direction of the external field, direction of E. That means if a dipole is, this is minus, this is plus, so dipole moment is along the electric field. The dipole moment, the electric dipole moment per unit volume is known as polarization, denoted by P. This is a term similar to intensity of magnetization, intensity of magnetization I. The polarization is directly proportional. The polarization P is directly proportional to the external field directly proportional to the applied field or external field. E. That is, P is proportional to E. In SI system, P is equal to XE epsilon 0 E, and in CGS system, P is equal to XE E, where XE, the electric susceptibility of the dielectric. It is a property of a particular substance. It is a property of a particular substance. The susceptibility is same as magnetic susceptibility, and a magnetic susceptibility indicates as how easily a substance is magnetized. And this is a dimensionless quantity. Dimensionless quantity. Total dipole moment PdV. This is dipole moment per unit volume. So total dipole moment PdV produces or induces a net positive charge to the right and equally negative charge to the left. Negative charge to the left, but net charge in the volume dV, net charge in the volume dV is 0. The positive charge to the right, the positive charge to the right is not cancelled by negative charge to the left. Thereby, a surface charge density. So, a surface charge density plus to the right and left, negative to the left. Thus, a surface charge density Thus, a surface charge density sigma p is developed on either side of the dielectric due to the bound charges due to the bound charges because in case of dipole one side is positive and another negative and they are bound in a molecule, but in case of conductor we are talking about the free electrons or charge carriers. Hence internal field EI opposes external field E, and EI is less than E, so net field inside the dielectric is not zero. So net field inside the dielectric is not zero.